Hi everybody, on today's show we develop an efficient way of representing inputs and outputs for functions. So we come up with a new notation for working with functions. So find the outputs, the y values, for each of the following functions when x equals 2. So I've got three different functions here. So with this equation, if I want to find the output when my input is 2, I'm going to plug in a 2. Y equals 3 times 2 plus 7. 3 times 2, 6 plus 7 is 13. So the output would be 13. For the table, when x equals 2, these are my inputs. This column's my outputs. When I plug in a 2, the output is 10. When I read the graph, I go to x equals 2. There's x equals 2. Where's the function? There it is, right there. Up 3, so 2 comma 3. The y value is 3. So it was a little confusing working with three different functions there, and it's kind of obnoxious to say input 2 to this function. So let's come up with this thing that we're going to call function notation. First thing is we're going to name the function. Most of the time we call them f for function. So we name the function with a letter. Could be f, could be g, could be h. And then in there, next to it, we're going to put our input in the parentheses. We're going to put our input there in the parentheses. And the way that you read this is f of x. F of x. F of x represents the output. This f of x here, this whole thing is the output. So what this is saying is you input x into the f function and find the output. Some people think it's multiplication. It's not f times x. It's not multiplication. It's saying input and multiplication. Input that into the function. So let's practice. So whatever's in the parentheses is your input into that function. So I've got the opening exercise functions here again, but I've named them. Notice this function is called f of x. This function is g. This function is named h. So compute the following. Find f of -4. So take a -4 and we're plugging that into the f function. So here's the f function. I'm plugging in a -4. Well, whatever I plug in here, so if I plug in a smiley face, it'd be 3 smiley faces plus 7. Whatever gets plugged in there replaces that x. So this is going to be 3 times -4, because that's my input. I want to know the output. -12 plus 7 is -5. -5 is the output. G of 2. So that's your x value, that's your input. So I'm going to go to the g function, and I'm inputting a 2. What's the output? G of 2 equals 10. This represents the whole thing that I'm going to say in a second. When I plug a 2 into the g function, the output is 10. That's a lot of words to say, so it's pretty easy to say g of 2 equals 10. And finally, we've got the h function over here, h of -1. Plug in a -1. So there's -1. What's my y value? It's the point -1, 2. My y value is 2. So that's your x value. The output is your y value. So in this box here, I have a bunch of different functions. I have f, g, m, k, and c. Let's go through and find each of these expressions. Let's see what they evaluate to. So if I say f of 6, that means I'm taking a 6 and plugging it into this f function. So f of 6 equals 2 minus 6 squared. I plugged in a 6 for x. 2 minus 36 is -34. So when I input a 6, the output is -34. M of 0. So I'm inputting a 0. That's my x value into the m. So here are my inputs. What's the output? 1. C of -1. I'm inputting an x of -1 into the c function. Here's -1. Do I need to go up or down at all? No, that's -1, 0. So what's the y value there? 0. Let's look at this k function. Let's read through this. K is a function such that for every real number x, k of x is x rounded to the nearest integer. So this function rounds the inputs. So let me round the input. How do I round 1.6? It rounds up to 2. I input a number, and k of x rounds it. Sliding on down. G of 5. If I want g of 5, I need to plug in a 5 to the g function. Well, g is 5x minus 1. So g of 5 is 5x. What's my x? 5 minus 1. 25 minus 1 is 24. K of pi. Well, this is really like k of 3.1415, blah, blah, blah. Well, how do I remember k is that rounding function? How do I round 3.14? I round it down to 3. I input pi, the output is 3. F of 1, I'm plugging 1 into f. 2 minus 1 squared. 2 minus 1 is the number 1. And I'm adding that to C of 2. C of 2. Well, there's 2. What's my y value? 2 comma 3. 3 is my output. So 1 plus 3 is better known as 4. And finally, m of negative 1. I'm inputting a negative 1. The output's negative 2. G of 0, g is this function here. G of 0 ends up being 5 times 0 minus 1. Because that's the g function. 5 times the input minus 1. I get negative 1. Negative 2 times negative 1 is positive 2. So what I've got here below is called a piecewise function. I've got a piecewise function here, and it's kind of like you reach a fork in a road. The machine uses different rules depending on what you plug in. So if you plug in specific numbers, you got to go to the right-hand turn. If you plug in a different number, you got to take a left-hand turn and go down that path. So here's f of x, and here are the two rules. I'm either going to use one of these two rules here. Those are the rules. I'm either 3x minus 7 if I take the right turn, or x squared plus 4 if I take a left turn. So I have to just figure out when do I use these rules. And these are the domains over here. These are the domains for which you use those rules. If you're smaller than 1, you use that rule. If you're bigger than or equal to 1, you use that rule. So the best way to get used to these crazy piecewise functions is just to practice with them. F of 3, my input is 3. Which turn am I going to take? Which rule is the machine going to process? Well, is 3 less than 1? No. Is 3 bigger than or equal to 1? Yeah, so we're going to use this bottom rule here, x squared plus 4. 9 plus 4 is 13. F of negative 2. Well, if I plug in a negative 2, where does that fall? It falls up top here. So we're going to use the top rule. 3x minus 7. Get negative 13. What if I want f of 1? My input would be a 1. Is 1 less than 1? I check the rule, the domain first to see where I fall. No, so I can't use that rule. Is 1 bigger than 1? I'm using that rule. 1 squared plus 4 gives me 5. So we're going to look at piecewise functions later on. I just wanted us to get in the practice of looking at them. Sometimes functions have different pieces, and you have to know which rule to use at certain points. Boiling water is at 212 degrees Fahrenheit is left in a room that's 65 degrees and begins to cool. Temperature readings are taken each hour. So this is the hour, and I'm outputting the temperature. T of 2. I'm inputting a 2. My output's 104. That wasn't too bad, but how do I interpret the meaning in the context of the problem? I can't just say the input 2 is the output's 104. That doesn't make sense in the context of the problem. Well, what does the 2 represent? This is 2 hours. I'm 104 degrees Fahrenheit. And I'm talking about the hot water here. So after 2 hours, the water is 104 degrees Fahrenheit. Notice I use units, hours, and degrees Fahrenheit, and I was talking about the context of the problem, the water. For what value of h does T of h equal 76? T of h equals 76. wait a minute, that 76 isn't an input, that's an output. So I know the output is 76. Here it is. What's the input? H equals 4. Notice here that sometimes we might need to find an input for a given output and work backwards. So you might need to look at your y values and find the corresponding x value. One more problem. Number 5, the graph represents the function s, which outputs the jogger's speed t minutes into her jog. Find s of 13. So my input here, my x value is 13. So I'm plugging in 13, there's 13. What's the y value? Right there, which happens to be in between 4 and 6, which we'll call 5. So it's 13, comma 5. S of 13 equals 5. What does that mean? Well, the 13 is my x, my minutes. The 5 is miles per hour. And I'm talking about someone's speed. So at 13 minutes, the jogger's speed was 5 what? 5 miles per hour. So at 13 minutes, the jogger's speed was 5 miles per hour. Or 13 minutes into her jog, the jogger's speed was 5 miles per hour. So the big idea with this function notation is you understand whatever's in the parentheses is your input, and you're going to try to find the output, the corresponding output. Because with functions, every input can only have one output. So when I plug in a 13, there can only be one number being spit out from that machine. I'll see you in the next lesson.